In this video, we're going to look at an example of changing the order of integration of a triple integral. So our integral is from 0 to 1, that's the outer integral, from 0 to z, the middle integral, and from y squared to 1, that's the inner integral, of some function f of x, y, z, and the given order is dx, dy, dz. And we want to change the order of integration to the new order of integration will be dx, dz, dy. So notice that the x order of integration, that is the inner integral, will remain the same. And so we can already have the limits of integration of the inner integral to be from y squared to 1. It is the limits of integration of the middle and the outer or left integral that we must determine. So again, our order of integration will go from dx, dy, dz to dx, dz, dy. So the x variable, the order of integration with respect to x, will remain in its position, while the middle variable and the outer variable will change places. So that means dx will stay in the same position, while the order of integration dy, dz will switch or change to dz, dy. And that's the key. And that's the key to solving this problem, realizing that. So let's put this into practice. So we want to first note that the first partial antiderivative, that is the inner integral from y squared to 1 of f of x, y, z dx, is a function of variables y and z. And that is because when we integrate with respect to variable x, or take partial antiderivative with respect to variable x, the variables y and z are left alone. They're treated as constants. And once we are done with taking an partial antiderivative with respect to x, we're going to replace every x with 1 and y squared, leaving all the y's that were there before and all the z's that were there before alone, and only variables y and z will remain. So every x, after taking partial antiderivative with respect to x, will be replaced with 1 and y squared. And so we can say that the partial antiderivative from y squared to 1 of f of x, y, z with respect to x will equal to some function of y and z. That's, again, the key to solving this problem. So we can rewrite the triple integral that we started with. So from 0 to 1, from 0 to z, from y squared to 1 of f of x, y, z dx, dy, dz as a double integral from 0 to 1, from 0 to z of g of yz dy, dz. And the problem now becomes reversing the order of integration of a double integral, which we've done many, many times earlier. And it is much easier than reversing or changing the order of integration of a triple integral. So first we're going to sketch the region of integration based on this double integral. And Then we'll reverse the order of integration from dy dz to dz dy, and then bring back the original partial antiderivative with respect to x, and the problem will be solved. So in this integral, we note that y is between 0 and z is between 0 and 1. And now let's sketch this region of integration in the yz plane. So y will be the horizontal axis and z will be the vertical axis. Here is the line y equals to z, and the horizontal line z equal to 1. And here is our region of integration. Again, notice carefully that y is between 0 and z is between 0 and 1. We now want to write this line as z as a function of y. Well, that's very easy. If y is z, then z is equal to y, and the order of integration 0 to 1, 0 to z of g of yz dy dz. If we reverse the order of integration to dz dy, notice that y is between 0 and 1, and z is between y and 1, and then g of yz dz dy. And now the problem is solved. Let's take the original triple integral. The original triple integral was from 0 to 1, 0 to z, y squared to 1, of f of x, y, z, dx, dy, dz. We wrote this as a double integral. The double integral was from 0 to 1, from 0 to z, of g of yz dy dz. We reverse the order of integration of this double integral to be integral from 0 to 1, from y to 1, of g of yz dz dy, and now replace g of yz with partial antiderivative with respect to x, and our answer is the triple integral in the order of integration dx dz dy. The inner integral remains from y squared to 1. The middle integral is from y to 1, and the outer integral is from 0 to 1.